Hi, I'm Judy McKay. I'm one of the directors at SQA, and I wanted to talk today a little bit about DevOps. This is just an introduction, just the webinar introduction to it. But for those who are thinking, I'm kind of wondering what DevOps thing is, people are talking about it at work. Is this something we should do? Is this something we should take on? What are the benefits? What are the risks? So just a high level overview here, give you enough information, well, to be dangerous, but to give you enough to, you can kind of participate in the discussions, understand what's being considered, and help make decisions if it's the right thing for your organization. So in a traditional organization, there's generally a separation between the development group, which includes testing, includes the requirements people, and the operations team. And the operations team is usually responsible for deploying software, maintaining it, and managing the production systems. Sometimes there's like a stage environment, which is some kind of falls in between. Sometimes it's used by the development organization, but it's managed by the operations organization. But in general, there's this kind of standard dividing line between the two. Now, you can see right there, there's obviously issues because people know stuff that would be helpful for the other people to know. So like the devs know how to deploy something, but do they get all that information across to the operations people? Or do the operations people have to do a few false starts before they figure it out? Operations people understand how to support something in production, and therefore they know things about shutting it down, starting it up, looking at logs. What kind of information do they need to know to troubleshoot? What kind of environment setup things do they need to know? Are there things that have to be configured when they move between environments? So there's a lot of knowledge that's pocketed in most organizations. And one of the goals of DevOps is to get rid of that pocketing, to share that information that's useful. So DevOps generally bridges that gap between the dev team and the operations team. And again, when I'm saying dev, I'm talking about requirements, development, and testing, just kind of grouped all together there. It brings teams together for the entire software development lifecycle, not just at the end. And this is a really important point here because I've certainly worked on teams where we got all ready to deploy the software, all excited about it, run to the operations guys and say, hey, we're ready. This is going to be great. And they say, no, you haven't given us 50 pieces of documentation, including the rollback plan, the data migration plan, all of these things we hadn't thought of because we were thinking in development world, right? That's great. We've tested it, got a bunch of test data. It's going to be great. Get it to the operations guys, and they're like, no. And you find out how much you don't know, but unfortunately you find it out at the very end when you really don't have time, because let's face it, how many development projects get to the end and go, hey, we have 3 weeks to spare, it's going to be great, now we can talk to the ops guys? Doesn't happen. So you're basically running down saying, hey, can you load it, and they're going, no, you need to complete our entire checklist of everything that has to happen. So getting the teams together for the entire software development lifecycle gets rid of those surprises at the end, because the surprises are no fun, especially when you've got schedule issues. And this way we can leverage that complete knowledge set. Everybody who knows how this system works, how it was created, and how it's going to run, how it's going to be maintained in production, we got them all together. So some trues and falses here. So DevOps, it is a methodology. It is a better way of working with the operations team. No question about that. And it's a great way to leverage skills and knowledge between the teams. But it is not the magical tool. It is not the do-all and end-all of all software development. Just like Agile, it's not the silver bullet. And it's also not another name for Agile. And I honestly see fairly frequently used in the industry, the two terms being used interchangeably. So that's a bit tricky because they are quite different. DevOps has that concept of integrating with the operations team. Agile doesn't. Now, just to add another level of confusion in there, when Microsoft decided to rename TFS, BSTS, whatever its many initials were, to Azure DevOps, a lot of people went, hey, we're using Azure DevOps, therefore we are doing DevOps. No. You can use Azure DevOps basically the same way you use Jira for bug tracking, for tracking stories. It doesn't have anything to do with that whole DevOps tool chain. It can be used for DevOps, absolutely, and it's great for facilitating a DevOps implementation. But just using the tool doesn't mean you're actually following the methodology. Now, DevOps is all about continuous activities. You've got continuous development, integration, testing, delivery, deployment, and monitoring. Remember that DevOps part, monitoring and production, very important part of DevOps, which means you also have to build the capability to monitor. So one of those things that you want to design in up front rather than tacking it on at the end. But it's a cultural shift, and it focuses on how we build systems and how we operate systems at high velocity. How do we get from the point where we're designing, we're developing, all the way through to getting this stuff out to production efficiently and at high velocity? So that's when we're talking continuous, right? It's always moving. There's stuff always moving through the pipeline. It's not like waterfall where we get stuck on a rock in our waterfall where we say, okay, well, we're waiting for dev to finish. We're all going to starve for water downstream. Oh, okay, we're ready for testing. Yay, testing. Okay, ops is waiting. Oh, okay, great, we're ready for ops. Now, it's not like that. We have this continuous flow going on. So there's involvement in all phases of the life cycle all the time. It's very inclusive of the people who make the software and the people who keep the software running in production. And that's an important thing to remember. So as soon as you're not seeing the ops people in your meetings, you're doing something wrong. So when we talk about continuous activities, we have the concept of, we'll go through each one of these in more detail here, continuous development, continuous integration, continuous delivery, and continuous deployment. So sometimes you see the CI/CD written. That's talking about the continuous integration and continuous deployment, but those include the others. So really CI is really the development and integration, and the CD is really the delivery and the deployment. So just kind of when you hear those terms out there, but CI/CD is pretty commonly used in industry. Now around these, we also have continuous testing. Now obviously testing has to start when we actually have something to test, and hopefully ends when we basically deploy. And continuous monitoring, where the monitoring capability is designed in up front with development, but it continues throughout the life of the product. Now in continuous development, that includes the requirements. So they're gathered, elaborated, refined, and tested. Now remember, testing requirements means you're basically looking at them, analyzing, making sure they're testable. If you're using stories, making sure you've got acceptance criteria defined, making sure that those are testable. All of that's part of the continuous testing. Then we have the code, which is unit tested, of course. Any noted issues are fixed. Now, important to remember, the idea behind a continuous process is we're not delaying stuff. We're not pushing it to later. So if we find an issue, we need to fix that issue rather than say, you know what, we'll actually fix all the bugs later. No, it's the idea is this continuous testing, continuous quality. So we're making sure that as something is found, we fix it. And that way we're not incurring more cost and more delay by letting it go on down the pipeline. And then continuous development ends at the point where our code is merging. And then we end up with merging our code. So the code merge capability. And that's making sure that each developer, as they develop their code, they unit test their code. They go, yep, my code is beautiful, and they merge it. Now this moves us into continuous integration. So at continuous integration, the merged code is tested. So we've merged it into the main branch, and now we're testing that as it's integrated into that main branch. Okay, so now important point here, only unit tested code makes it here. So developers can't slip this stuff in without unit testing it. And that again is a serious, or can be quite a serious mind shift for people to think that, you don't just release your code because you're done with it, you release it because it's actually ready to be merged. At integration, the code is checked for conflicts. So, for example, if you had two developers working on modules and they overlapped with some of their modules and they both tried to check in, it would say, oh, no, wait, you guys have to sort this out because one of you is going to overwrite the other. And code coverage and the unit tests is assessed at this point. So this means you're using a tool that's basically saying, what is my code coverage? Did the unit tests actually cover as much as they were supposed to? Then once we've made it through the merge and the integration, we do the build. So the build code is tested, successfully built. Now, again, builds fail sometimes. They often fail because something wasn't checked in correctly, because somebody checked something out, didn't check something back in, or it's just flat out doesn't work. So we have to make sure that the build is successful And if there's an unsuccessful build, we roll back. We don't say, we'll just kind of stop here with code that actually doesn't work. No, we go, you know what, we've got to have continuous. We've got to roll that thing back if the build failed so that we always have a good build ready to go. Continuous delivery, and this is where we're talking about the test environment. Okay, so we create the environment, and we'll talk about infrastructure as code, but this is, I think, one of the coolest aspects of DevOps. And we make that environment created. So we basically spin up the environment, we release the code, we install the code to the environment, and then we verify that the code was installed correctly, which we do by testing, running our automated test suite, making sure that we had successful execution. Doesn't count if you just run it and you don't check to see if it actually worked. You do have to verify that it did. Now, continuous deployment is actually in the production environment. So it's kind of a bit confusing because the terms are similar, but continuous delivery means we're delivering it downstream into that test environment, continuous deployment onto production. So the tested software is deployed to the production environment. The deployment is validated again. So we're still testing, right? We know we want to make sure that after we've done our deploy to production, we actually validate that it worked. Because sometimes you can do a deployment and you didn't get a failure on the deployment, but it actually isn't working because we missed configuration parameters or something like that. So we have a test that runs in the production environment to make sure that our deployment was successful. And then we go into our monitoring, because the monitoring stage is what ends up with the rest of the life of the product. Now, continuous testing. This is probably the most critical part of DevOps. This means that we have repeated execution of tests against the code base as the code base moves through the stages. So there's a quality gate for every step in the pipeline. You can't go to the next step until you've proven that you have quality built in. So that's why you have, and because we're not trusting people, we test for this. We make sure that we've got this continuous testing that occurs at every stage to make sure that we haven't broken something, or if we have, we can roll back, fix it immediately, and then move forward. Unit testing, integration testing, build verification, deployment testing, all of those are automated and all of those are continuous. They have their place throughout the life cycle and throughout the DevOps pipeline. So we have to make sure that all of those tests are in place and they're ready to run. Now, obviously, this is going to increase confidence that we're not, having poor quality sneaking up behind us. Makes a success factor for the eventual deployment, right? So we're not going to deploy stuff if it's failed its previous steps, which means we're not going to get a corrupted build in the test environment. Don't know if you've ever had that luxury when you've actually had a bad build delivered into the test environment and you're down until you can actually roll back to a previous build. So this makes sure that because we've been testing all the way along, by the time it gets to our test environment, should be good. But if it's not, we're testing immediately as soon as we do our deployment when we can roll back. So there's automated rollback built into this too. The testing has to be integrated with the development and the development team though. So the developers have their part to do on the unit testing, on the build verification. They have that part, but it also needs to all be automated. So it's all got to hook together with their tools and their development tools as well. Now, another part of continuous testing that sometimes is forgotten is performance and security. Because in a lot of cases, performance testing and security testing are done last. The problem is performance problems and security problems are usually introduced quite early. So the sooner we can run those tests, the better. And this is when you think here about DevSecOps, which is talking about security testing incorporated into a DevOps. That's what it's talking about. Now, in a lot of cases, because you're going to start testing as soon as you have code, using stubs and drivers or virtual services is a good way to be able to make progress on testing, especially on test automation, before you have all the code pieces together. So being able to use the stubs and drivers effectively, knowing how to spin up a virtualized service, that will be tremendously helpful in implementing the continuous testing. Now, continuous monitoring, this is where our ops people come in, being able to monitor in production, making sure we're getting good performance, making sure our environment is staying stable, and then of course also monitoring throughout the process. So making sure that we are progressing smoothly, that we have met our quality goals, that our tests are passing. All of that is part of continuous monitoring. So it's not just the dashboard at the end that's looking at production, it's making sure that we've built monitoring into the whole process And I got to tell you, nice dashboard is really helpful here too, so that we get a red flag as soon as something fails somewhere, and we know, and that way we can address it quickly. Kanban boards can be really helpful with this, making sure that we have the basic stages that we go through and that we're monitoring at each one of those stages. Critical component, continuous quality. Unless the team is focused on continuous quality, you may just have continuous chaos. So that focus has to be there. That means that every testing step, that continuous testing, every monitoring step has to be looked at and say, are we at the right place? Are we getting the quality that we're expecting or that we require? And if not, why not? And if not, we need to stop now and fix it and go back and figure out what we did wrong. This is not stuff you fix later. And this is a very important mindset. It's not later, it's now. The quality matters right now at this step, and we don't go any further until we fix it. So that focus on continuous quality has to be pervasive throughout the entire team and throughout the entire life cycle. And of course, automation is going to be king here. You can't do continuous testing if it's not automated because you just don't have time, right? As soon as you've got to run in there and type in your things and run your tests and go, okay, we're ready to go. It just takes too long. It's got to be automated. And this is why the stubs and drivers, virtualized services, those things become very critical because we have to build our automation quite early because you want to use it all along. And then, of course, keeping in mind that the automation is continuously growing too as we get more code, as we learn more, as we get more capability in there. We want to make sure that our automation is continuously growing as well. So DevOps automation isn't just testing, it's about automating the whole process. So it's easy to think, oh, okay, we've got test automation, therefore we're automated. Are we? Are we really automated? Because as soon as you're having to stop and do something manually, like, oh, I gotta go trigger the build manually, or oh, no, it failed, I gotta go make a report that it failed. Automation is talking about end-to-end automation, meaning the less manual intervention we have, obviously the better this is going to work, and the smoother it's going to be, and the faster it's going to be. So continuous testing, absolutely, got to have that. And automation of that continuous testing, got to have that. But that automation concept is bigger than just testing. So in automation in DevOps, in Agile, you basically have the unit testing that the developers do. You have acceptance testing that the product owners do. And you have that concept of continuous integration. So we've got a story through, we've unit tested it, the product owner said, oh, that's awesome. It gets integrated into the whole. And then you go back, do another story, right? It's kind of that start and stop. Whereas with DevOps, we have that continuous testing deployment all the way through. So we have that concept that it's going, pretty much start at the beginning, build that whole continuous testing in there, and then we can just continuously deploy because we know as we're deploying, we've already gone through the whole testing chain. We don't have to do this stop, start, stop, start. And you notice in Agile, for example, we have the dev concept and then we have ops coming in at the end. But in the DevOps world, we have the developers and the operations people all working together all the way through. So a very different concept when it comes to that. Much more fluid for DevOps, quite frankly, much faster once it's implemented. I mean, obviously you can say, yes, we're going to have automated testing for everything, but you do have to implement that. And that does take some effort, and maintaining it becomes critical. So it's not like this is easy to do, but it's a lot faster, it's a lot safer when it's all in place. And that way you're working more continuously, more smoothly, and there's less surprises down the road. Because let's face it, as testers, the earlier we can get involved and the earlier we can look at it and go, yeah, that's, I've built this test, I've got my stub, but it just doesn't seem to be working correctly. The sooner we can get on that, the faster they can fix it. And that's going to make everything move more quickly. So that old thing of building quality in, well, it's the only thing that's going to help your schedule. Well, DevOps proves it because you have to do that testing and you have to do that up front. Now, infrastructure as code. This is just a lovely thing because, if you've been in testing for any period of time at all, you know what a pain it is to get environments right. And what infrastructure as a code does is it says, you know what, we're going to create the environment every time we need one. And that means that we have to have the full process. we have to have the technology, we have to have all of the configuration parameters, all of that stuff has to be scripted, basically. So we're not saying, oh, I need this guy to come and do this configuration thing, and then I need the data guy to come and do this, and then I need oh yeah, I gotta get all these guys together. No, it's all been put into code. Now you talk about needing to grow the maturity of an organization. This really does it, because now suddenly you can't go in and just twiddle with the settings and make it work. No, it has to be coded. And then it has to be tested, because you're going to say, okay, infrastructure is code. I have no infrastructure. Boom, here it is. I've run my code. Oh, it's missing 5 configuration parameters. Okay, got to go fix the code. I don't go fix the environment. I fix the code, and then I run it again. And what this does is that you get away from this problem of people changing configurations and not telling you. You get away from the problems where the test says it works in the test environment and it doesn't work in production. And it saves so much time, but it's hard to do. You really have to have the ops people on their toes here to help you build this. Virtual environments are easy to do with this because you can, of course, spin them up very quickly, but you can do it on physical environments as well. It doesn't really matter. The whole idea here is that you have complete control over what goes into that environment. Therefore, you can create it. Other nice things is when you say, you know what, this tester's like, we just need another environment. We need an environment where we're going to do performance testing, or we need an environment where we're going to do some data migration, or we need a special environment for something. Now it's easy. You've got infrastructure as a code. You can spin up an environment with no problem at all. So this is probably one of the best developments that's come out of DevOps. It was around before DevOps, but DevOps kind of captured it. But that infrastructure as a code, being able to actually generate your environment, man, it saves time. So should be with no manual intervention. You run a program, a script to do this, and it sets it up. As soon as you're intervening manually, now you've broken it, right? Now you don't have infrastructure as code. You have infrastructure as code and some manual intervention, right? So you want to make sure that there really is no manual intervention required. Does require the ops team be engaged. It does require that the developers are quite clear on their configuration parameters, what the settings are, when the settings should be changed. And it really improves developer understanding of the infrastructure and, quite frankly, tester understanding as well, because you got to know up front what that environment's got to be. Therefore, you really have to think about, oh, okay, I've got to call out all of these different configuration parameters, and I've got to call out, oh, I've got to create data. Oh, okay, well, then I need to be able to export data and import data. It gets all of that incorporated in there. So you can get that whole environment created. I mean, obviously you can go bigger or smaller, but to make it work with, the old cliche of a touch of a button. So the DevOps tool chain is what makes the DevOps pipeline work. Now, what's in the tool chain though? It's pretty much everything. So when you think about tools that you need for projects, right? Project planning and management, requirements tools, configuration management tools, build tools, continuous integration tools, source code scanning, things that can look at like the quality of the code, do some analysis of the code, check for security flaws being built in, being able to automate functional, non-functional testing, deployment as well. And there's a lot of tools out there that do this, and help with some of these things like Octopus, and some of those can be really helpful. And tools change all the time, so I'm loath to name very many tools, but thinking about what kind of tools you're going to need and how they're going to work together. I mean, it's great to have your pet tool, but remember, it's a tool chain, right? If you don't have these things all working together, you're going to have trouble, and you're going to end up with somebody having to do manual intervention. And as soon as you've done that, you've just slowed down your whole thing. Your continuous has become a problem. So lots and lots of tools. Continuous testing, obviously, application and infrastructure monitoring tools. Don't forget performance. Don't forget security. So all of those become part of the tool chain that you have to have. So can it work? Well, yeah, it can. And some benefits. Assessing quality at every stage. You know exactly where you are. You don't end up with this technical debt building up behind you that you're going to have to worry about later. You know that what you have produced is of the quality that you need it to be. You know you've got it. You don't have a surprise when it comes time to do your to put this out into the production environment, because you know how the infrastructure works. You've actually got it all coded and documented, I hope. You can release small increments frequently because you have the tool chain in place. You have the whole pipeline in place so that you know that each one of these little releases is of the quality required because you've tested it all the way along. You can get an on-time and lower cost delivery. Now, again, you got a lot of upfront costs with this because you've got to do a lot of building your tool chain, basically, making sure that your automation is in place, doing your infrastructure as a code. That's upfront cost. But you can really lower the cost of delivery because you have higher quality, you're going to hit your schedule better, and you're going to end up with a product that people actually want. Now, another benefit, if you're using vendors or third parties and you need to get response back fast, say you're integrating some of their code as well, you can get that information back to them very quickly because you've got the tests in place, you've got the monitoring in place. So you can say, you know what, these guys are giving us the integration between these two things. Excellent. I'll put it in, build it, test it. I know immediately if it worked or not. So again, you can get a faster response, and that helps to reduce any issues that would come up later. And ideally, of course, we have faster time to market with higher quality, because if we've done it right, it is going to be faster. I mean, it makes sense, doesn't it? And that way, when we need to make a change or we need to add a new feature, it's easy, right? We already know how this thing needs to work. We've already got all the tests in place. So we can respond more quickly to changes that occur. But there are definitely risks. So sometimes there's a lack of buy-in in an organization. They want to protect their traditional roles. Like ops people will be saying, well, why do you need to know that? Or developers will go, I don't really want to define all the configuration parameters. I want the flexibility to change them later. So you can see there's a fair amount of give and take that has to happen because it has to be pretty open and pretty obvious in order to share. Sometimes continuous is not. It's more of a stop and start than a continuous. And unfortunately, as soon as you've got that manual intervention or things that cause the continuous process to not be continuous, now we're starting to lose the things like our faster time to market, our ability to respond quickly. Those kinds of things are affected. Quality can be pushed downstream, and that is a bad one because that basically breaks the whole concept of DevOps, where we have continuous quality, continuous testing. So as soon as we start to see quality being, we'll get to that later. Yeah, there's some bugs, but we'll fix those later. And you just work around that area. That doesn't work. It's really breaking the major concept here of DevOps. So you have to push back on those. And hopefully you have your automation in place and you can say, no, it failed. We need to fix it now. And which brings us to our next one. Sometimes automation lags behind because as testers, right, sometimes we can't get all the automation built. Again, this becomes risk-based. You need to go after the big things first, right? Fix the problems that are the scariest first. Make sure that you're testing the most likely to break stuff and build the automation as time progresses. The team might not be technically capable. This does require a fair amount of technical expertise here to do really good automation, to get that whole continuous testing in there, because you've got a lot of tools at play. They've got to all integrate together. They've got to pass data. You've got to get dashboards in order to get monitoring. You've got to do infrastructure as code. This is not simple stuff. So again, great opportunity to build and develop, but you can't say, poof, tomorrow we're going to be DevOps. The team has to learn how to do that. And that goes along with the bottom one here, the time for adoption. You got to be realistic. The team's got to learn. The team may need some training, may need some new tools. You can't just say it's magically going to happen because it does take some time to adopt it. And, it's one of those things that you get better the longer you do it. So this was just a quick taste here, just the highlights, quick view of DevOps. We offer a micro-credential so you can learn more about the testing aspects of DevOps, and it's kind of one that I would consider necessary if you're going to enter the DevOps world. It gives you enough information so that you know the terminology, you understand how it's used, gives you a lot about what you need to watch out for, making sure that before somebody says, yeah, DevOps tomorrow, you can actually say, oh, wait, what about these things? So the micro-credential, really great way to do that. And then we also offer a full certification in DevOps. So full look of what DevOps is, how to implement it, the pros and cons, risks, All of those things are discussed in a lot more detail. So see the @SQA website for more information where you found this handy webinar, and learn more about DevOps. It's a great way to go. It's a tremendous opportunity. You just have to know how to do it right, and you have to understand what you need to watch for in case things are starting to go off the rails. Hopefully this was helpful for you. Thank you very much.